So now I'm going on to part C. So I retain the algebra that I had set up in part A, and also from part B, because of the similar triangle, I have the 3 ratios. So for part C, you are asked for another pair of similar triangle. So for part C, this is a state. So you need to state the triangle that is similar to ECD. So there is no need to prove. So locate your ECD first. So look at your ECD. Your ECD has a 90 degree, has a X. So your ECD has a 90 degree and has a X, and because of angle sum, we got a 90 minus X. So you should look for another triangle that has X that has 90. So the more obvious situation will be this one. This one has a 90, it also has an X. So remember I mentioned about matching. So matching the angle. So you match according to the value. So in this question, right, this is a X. So you match with the X. So this is a 90. You match with a 90. Then the subsequent one will be B. So you match according to the algebra, according to the value. So on part C, you do not need to prove. You just have to state. So after you state, you also should link yourself to the ratio. Okay, so link the ratio. So I'm trying to find something common with the previous ratio. So I detected that there is a EB here. So I'm going to list out the ratio. So EB over ED. So you carry on with the listing. So for example, BC over EC, and then CE over CD. So you are just listing out. You don't know how it's going to help you at the moment, but you know that for similar triangle, the ratio will always be valid. Okay, so after that, right, how will that help me with the part that I wanted to prove? Okay, I also wouldn't be able to see it. So I usually will cheat this part. I usually will cheat this part, okay, by looking at, so I got the AB, I got, okay, hang on now, did I write wrongly? AB, I think I wrote something wrongly. This one I wrote wrongly. So AB should correspond to AE. Okay, so I detected a AB, I detected a AE, which is the same as this part. So I work backwards. I'm going to work backwards. Then I'm going to work backwards here. And as I work backwards, I realized that, hey, I got this thing here. And here I got here. So it's a bit messy because you're staring at a lot of alphabet. So that's why you cannot make mistake. So just now I make a mistake. And I realized it because I realized that something is not matching. So, okay, so as I copied from my previous slide, I didn't copy correctly. Okay, so now how are you going to do that? And these two, right, are linked by a common ratio here. This and this are the same. So we're going to piece them together. So how am I going to piece them together, right? From this pair, I'm going to write out these two. From the pair that I stated, I'm going to write out the 2 ratio. And from part B, I'm going to write out another ratio. From part B, I'm going to write out these 2 ratio. So it's the equation 1 and equation 2. So you got to cheat from whatever you're supposed to prove. You got to write out the ratio. There will be a lot of ratios. That's why you got to like be focused. And then after that, if you compare 1 and 2, if you compare 1 and 2, so this and this are exactly identical. So it's a bit like equation 1 equal to equation 2. So this will be equal to this. And then you cross multiply backwards. Now you cross multiply back. So there is a lot of scribbling first before you can even write out the proof. So you got to cheat from the proof, knowing that it's some ratio. You got to write out the ratio from the similar triangle. So in this question, we got 2 pairs of similar triangles. So you got to be writing out. You got to be patient with it because you're seeing a lot of alphabet. It can be very frustrating sometimes because all you're looking at is a lot of chain of alphabets. So that is part C.